Okay, continuing on with our transformation. This one's a little trickier. Our function that we started with is not a parent function. It's actually a function that has multiple x's in it. So let f of x be x to the third power plus x to the second power plus 1. Now remember with these, x's always have the parentheses around just the x if you don't have anything added or subtracted to it. So I want you to write a rule for g and then graph g. Right? Describe the graph of g as a transformation of the graph of f. Okay, so here's my g. G of x is equal to f of negative x. And since that negative it means reflection, I know that the description is a reflection over, now I have to decide whether it's reflecting over the x or y. Since that negative is on the inside, remember inside is a horizontal movement. If I'm taking a point and I'm reflecting left and right horizontally, I'm reflecting over my y-axis. So this is reflection over y. Well, let's write the new equation, the new rule applying that negative to it. Well, we started with f of x is equal to x cubed plus x squared plus 1. And since I'm reflecting over the y, I'm adding, or not adding, multiplying a negative to each of the x. So in this case, my g of x is going to be, I'm going to take that negative, take that x, multiply it by negative before I cube it. So now there's a parentheses on around negative x. Plus, that's another x, so I have to multiply that x by a negative also before I square it. Plus 1. And then let's simplify this. So g of x, it's equals to negative x times negative x times negative x. So that's still going to give me negative x cubed. Plus, I have a negative x squared. So negative x times negative x is going to give me a positive x squared plus 1. And that's going to be my new equation right there after work simplifying it. And if I were to graph this, this is my f of x. It graphed it for me. Since I'm reflecting over the y-axis, I want to definitely take a couple of points that are lattice points. Right? That makes it a little easier to reflect and take each point and reflect it over the y-axis. So in this case, it'll be over here. This one stays here. This one reflect over here. And because there's a little bump, a little curve, I'm going to take that and reflect it. It looks like it's right about there. So reflecting over the y-axis, I get this graph right here. It goes this way. And then looks like there's a bump and it goes this way. And there is a graph reflected over the y-axis. Let's take a look at part B. This one has 3 times the entire f of x. That means it's a vertical movement. It's a vertical stretch or shrink because it's a multiplication and it's multiplied onto the whole thing. Vertical stretch or shrink by a factor of, and because it's a multiplication on the outside, that 3 is going to stay as 3 by a factor of 3. 3 is a number greater than 1, so I know that this is a vertical stretch by a factor of 3. So to multiply, notice that it's 3 times the entire f of x. Again, my f of x is x cubed plus x squared plus 1. And they want me to take the entire equation and multiply by 3. So my g of x is going to be 3 times the whole f of x, x cubed plus x squared plus 1. And to simplify, you're going to distribute my 3 into that equation. So g of x is equal to 3x cubed plus 3x squared plus 3. And that would be my simplified g of x. Again, I do the same thing on the graph. I'm multiplying the y value, the entire equation, by 3. So pick out a couple of points with some good y value here. Might want to do that little vertex right there. So we have, let's see, start with this one. I'm going to take this. This has a y value of 3 multiplied by 3. It's going to give me 9. So there's my new point right there. This is a y value of 1 multiplied by 3 is going to give me 1. Y value of 1 multiplied by 3 is going to give me 3. And then last but not least, y value of negative 2 multiplied by 3, negative 6. So it's definitely down, way down over here. Let's do a quick sketch. Okay, it's going to go down here. I know there's a hump before it moves down. Notice how it got stretched vertically, meaning that it got closer to the y-axis. The last thing we're going to do is we're going to take a look at the last example. It looks like the last example says, let the graph of G be a vertical stretch by a factor of 2, followed by 3 units up of the graph of f of x. Oh, so it looks like they want you to write the rule for G. So here's G, here's f. That's what I'm starting with. So I'm going to do x cubed minus 2x squared. I'm going to write that down. I'm going to do it one step at a time. The first thing they want me to do, because I'm always going to go in the order that they tell me, of the description that they tell me. It's a vertical stretch by a factor of 2. When you do a vertical stretch, vertical means something that applies to the entire equation on the outside. So I'm going to take this entire equation, x cubed minus 2x squared, and stretch it by 2. So from there, simplifying that, distributing 2 in there, 2x cubed minus 4x squared. From there, I'm going to follow that by 3 units up. 3 units up means to take the entire equation and add it 3 units. So simplifying that, you get 2x to the 3rd power minus 4x squared plus 3. And since that's all the transformation they want me to do, they want me to write a rule for G. That means I label this G of x. And you got a final equation for G of x.